and other. So what happens is you basically, will, first of all, you have your Ethereum wallet out there, and then like I said, you'll create a test app. You'll create an API key where people can access your work, or you can test your work. You normally use a test network. So there's multiple test networks for Ethereum. If I'm saying this right, Gorelli, there's other test networks as well. Some of them are being deprecated. Gorelli is a test network. You can get, kind of like fake Ether on Gorelli. I wouldn't say fake Ether, but Gorelli Ether, which is not really worth anything, but it basically it lets you fund your projects on these test networks. So basically, it's a network that runs. It's just like Ethereum. It is really part of Ethereum. It runs side by side with Ethereum, but it's for test applications. And so you can test things on test networks, and then you can move things into the main Ethereum network if you wanted to. But basically, you would use an app like Alchemy, and I'll show you Alchemy as well. So like I said, you normally create an Ethereum account. You can do that using MetaMask, basically creating an Ethereum wallet. You can use that with MetaMask or any other Ethereum wallet as well. Like I said, I like MetaMask because you can basically look at things on the test networks as well. And then basically you would connect your wallet to the network, the Ethereum network, and you can do that for Alchemy. So once, like I said, once you create basically a smart contract, once you are on this test network, you need to fund your network. Remember I said, when you put stuff in the Ethereum blockchain, you kind of have to fund it. It's powered by the Ether, tokens. But you don't want to spend money on creating test applications to see if they work or not. So that's why we use these test networks as well as Ethereum test networks. Gorelli is a test network. The nice thing about Gorelli and other test networks is they have this concept called faucets. What a faucet does is it basically gives you these test Ethereum tokens. So basically, you need to cover the transaction costs of the Ethereum network with a smart contract. So there's always transaction costs that happen. As I said, some of these these marketplaces will kind of take care of the transaction costs for you when you sell an NFT. But let's say before you even get to an NFT and you want to do this on your own, you don't want to use a smart marketplace or a NFT marketplace. You kind of want to price things on your own. You want to create a contract. Well, that means you got to fund it on your own, and you probably don't want to spend real money using things that may or may not work. So you want to put it on a test network, but you still need to fund that test network. So basically, these test networks have this concept of fake Ethereum. So the Gorelli test network has Gorelli Ethereum, and basically it's not really worth anything, but you still need to fund it. So because it works and acts just like real Ethereum. So for your testing purposes, so you need to get that. So there's a lot of websites called faucets. What a faucet does is it'll give you these test tokens to test as well. We should demo this, so it'll make a little bit of sense. There's also toolkits. So one of the more popular toolkits is called Hardhat. What Hardhat is it lets you actually write projects. It lets you interact and write projects in different configurations for Ethereum so it's actually a programming environment. So you normally use this. You'll normally interact a Hardhat with maybe some other program like Microsoft, Visual Code or something like that. You import, your Hardhat files into Microsoft or Visual Code and write a smart contract on that. But basically, Hardhat, like I said, it's an environment to essentially write software and smart contracts on the Ethereum network. As I said, normally I don't like just working in Hardhat. I like working in an IDE editor, like Visual Code. Microsoft Visual Studio Code. So it just looks a little nicer, and basically you tie Hardhat into Microsoft Visual Code and you write there. Smart contracts are usually written in Ethereum in a language called Solidity. You can write in other languages as well, but that's kind of the more common language. It's very, very much like Java, I would say, very, very similar to Java and JavaScript in some ways. This is kind of how it looks like, the code. You'll see you'll see program, you'll see Solidity. This is actually in Visual Code. Let me see if I can bring up something here real fast. 1 second here. All right. So this is basically the MetaMask website. You can see like from MetaMask's website. This is like where I would get my wallet. Right. You can just go ahead and click download for Brave. It'll kind of detect what browser you're on. I already have it installed on my browser. That's why it says remove from Brave instead of just like downloading it. Here's right here. Here's MetaMask right here. You can see there's an Ethereum network out here. This is my Ethereum address out here. I can copy and paste that. I can go to Etherscan. I can put in my address out here. Basically, I'm creating the Ethernet, Ethereum blockchain. You can see there's no transactions because this is just a test network. I haven't done anything with this as well. But I can also, when I go up here, I can see that I've added, and you got to go to an options to add this, but you can see that I've added to show me the test networks, and you can see there's multiple test networks here. The test networks you kind of have to have something that interacts with the test networks. Borelli, I think, is kind of like, well, it used to be like Roastin used to be like kind of the most popular test networks. I mean, they're all kind of popular, but like with Alchemy, since I use Alchemy, I use Gorelli test networks. That's kind of the more popular test networks that are out there as well. So let's copy this one, and you can see I can scan this with Etherscan as well. Basically, if I go to Gorelli.etherscan instead of just Etherscan, I can see the test network here, and you can see that I have a couple of transactions that have happened on the test network. So it just lets me kind of like view the network and then view what happens here. This is Alchemy's website. Let me see if I can just log on here. So this is Alchemy's website. You can see that I have a couple of projects here. There's a demo project which is default. There's this Hello World program that I started creating for this class. So I can create multiple projects on here. And when I create these multiple projects, I can essentially look at my API key. So when I want to interact with this with Hard Hat or something, and I want to basically interact with this website directly, this development environment directly, I can do that as well. There's also this Composer app. Let's click on Composer. I could do this directly, directly on through a command line or command tool as well. But this kind of lets me do it for me. It kind of builds the code for me. So say if I want to do see my Ethereum balance, I'm gonna do my Ethereum balance. This is my address. This is my Ethereum address. It's already pasted into here, and basically I can see that there's nothing because I have 0 Ethereum. This is just a test wallet here. But if I go to my Gorelli network over here, I can do the same request here, and basically I see a result back here. This result is hex out here, so I have to go to a hex editor, and basically if I do this, I can see that there's a balance on here as well. There's a decimal number. If I go back to my Gorelli here, I can see that number matches a little bit. There's probably more decimal points here, but you can see it's not exact. There's no decimal point here. Well, it's because this number is actually in what we call Way. So Way is basically the smallest amount of Ethereum you can get. Basically, one Way, basically one Ether equals about 10 to the 18th power of Way. So Way is a really small unit of Ether. It's the smallest unit of Ether you can transfer. So that's why the number here is so big, and it's in a power of 10. So that's basically, like I said, we may get actually more into the development environment if we have them actually thinking maybe we should extend this class and actually write the code out ourselves. I think it may help. Oh man, I just saw your text is I'm using a 4K monitor, so sorry about that. Is a Solidity object oriented? I never really looked into it. I don't think it is. I mean, I've just really kind of used it. It's a I'm not sure. I have to look that up. But it's pretty simple to use. Like there's a lot of tutorials on it. It's pretty simple to use. I believe it is, but I'll double check. Yeah, please maximize your screen as well. That sometimes helps, but like I said, I was using a 4K monitor, so it may not help. All right, let's move on. I know you guys have a few more questions, but let's just kind of move on. So as I said, when you're kind of doing this, when you're kind of like, first of all, using like, MetaMask, you first create a MetaMask wallet. When you do things manually, as I said, if you're using like a marketplace for NFTs, you don't have to do any of these steps. But if you are doing things manually, I do run another class where I actually like assign, like I do like a certificate of completion on the blockchain. So instead of like printing out a certificate of completion, I think it's kind of cool to put it on the blockchain. So I do a certificate of completion on the blockchain that anyone can query. I actually put it on the test network, so I don't have to like actually pay for it or anything. But you can query that test network on EtherScan, and you can see your certificate of completion for a class that I do. But like I said, essentially what you do is you've created your MetaMask wallet. That's the first step you've done. You created a MetaMask wallet. You go in and create an Alchemy account. At least in my case, you don't have to do this with Alchemy. I just find there's a lot of tutorials out there, and so when I tell students a lot of times. So I do run like a whole class on creating like smart contracts. It's like a week-long class, but I just find it easier for students to do. And by the way, guys, I'm coming out with like a recording that I'm gonna put out on YouTube. It's gonna be like 6 hours. Like gonna be breaking up on like it's gonna be all free on how you do your own like step by step. We're gonna create like the multiple smart contracts and the NFTs from scratch and not using any third-party websites or anything like that. Web3, I would say Web3 is probably the most important. That's probably used most often. But yeah, if you can get pretty good at Web3, I think you can be really good at a lot of these technologies that are out there. But let's say you create your MetaMask wallet, or you create some account on something like Alchemy. You have an API with that associated with that. You basically will write your own contract. You'll basically, and there's a lot of examples out there. If you do want to write this, like I said, I don't know if we'll have time to actually go through a contract and write a contract, but if you're like, you know what, I actually want to go through the steps of writing a contract, I promise you it's not hard at all. It'll probably like, if you have zero experience with coding, it'll probably take you about 40 minutes. Email me next week. I'll put together something, and I can give you guys like a good tutorial like on how to write your own contracts, and kind of give you some pointers, some tips, like tutorials that are already on YouTube and stuff. But I think I'll probably add it to this course. We'll probably just add like some time to this course, and we'll do that. At least I'll walk through that. I think that'll probably be really helpful. But like I said, you can write your own smart contract using VS Code. And like I said, even if you've never coded before, trust me, you can follow the examples. It's very, very easy. We can write like a hello world program. We can write something very, very simple. And then basically you connect all the pieces together. You basically write environmental files, like in Hardhat, you have an environmental file that basically stores your password, your API key, things of that nature. So basically it connects your wallet, your MetaMask wallet, your Alchemy account, or whatever development tool you're using, environment you're using, as well as your VS Code and your actual code. So pretty simple to put everything together. And like I said, you create these files in VS Code. You extract your private keys in MetaMask. You never kind of want to extract your private keys and tell anyone what those private keys are, because if those get out, everyone knows what it is. So there's a secure way of doing that, and making sure it's not like just searchable on your code, especially if you're going to publish this on the internet. And same thing with your API keys as well. I know that's a little fast, but just bear with me just a little bit. Guys, I'm gonna actually put like what we call a pulse check here. You're gonna see like a thumbs up or thumbs down. Can you give me a thumbs down if you haven't taken the first course, part 1 of the course, and give me a thumbs up if you have. Real fast. So I just want to see how much time I'm going to spend on this, or how fast I'm going to go through this. So please see if you see that on your screen. It's like a pulse check. It will be like a thumbs down. I'll just give you guys like a second to do that. Do you guys see that? Okay, at least one person sees that. So, okay. Okay, I'll just if anyone else can do it, I'll just give you another like 15 seconds. If you guys can just, if you haven't done it, please put a thumbs up if you have taken the part 1 of the course, and thumbs down if you haven't. So VP, I like what you said. Like writing a smart contract is not too. You're right. There's like a ton of examples you can follow. You can pretty much copy and paste like the code for a smart contract. You're right. Making it secure is not only difficult from like the actual security part of it, but it's also from the logic part of the contract as well. A lot of people that copy and paste contracts, they're obviously changing what that contract wants to do. So securing that contract means a lot of different things. Like, first of all, making sure the code is secure, making sure the infrastructure that's running that code is secure, depending on how you're running that, if you're running like private blockchain, and also making sure the logic in that code like can't really be exploited, like not doing anything on that level. All right, guys, I think that's enough time. I'm gonna go ahead and end the pulse check. We got quite a few people that haven't taken the first course, but it looks like the majority, by far the majority of people have taken the first course. So I'm not going to spend too much time on this. I know that's not gonna go well for the people that haven't taken the course, but so I'm gonna hit just a few things. But I've talked about this in my first course in detail, so I'm not gonna go over like all the different things. I'm just gonna go over some of the easy examples. Please bear with me if you're taking the first course, but I'm not going to spend too much time on this. I just want to make sure everyone's on the same level. This is kind of the example I gave in the first course. Is like an encyclopedian example. When you have like a set of encyclopedias, a physical set of encyclopedias. I kind of went through this example in my first course, and what happened? All right, there we go. Like I said, I went for this example. I had this great story. I'm not going to repeat that on the first course, since, like I said, the majority of people have heard that. But basically, I talked about how information can get dated in an encyclopedia, and guys that haven't taken this first course, they're like probably like, what the heck are you talking about? But I gave this example where basically, I did this report as a kid, and basically I did a report on Pluto. At that time, it was like the 9th planet. Obviously, today it's not rated as the 9th planet in the solar system anymore. That information is outdated. Normally, what happened in the physical world is you have like updates to the encyclopedia. Basically, the encyclopedia company decided like, hey, you know what? We're gonna send you out, a new encyclopedia set, like basically an update set, and basically, the central authority, the academic American Encyclopedia Company, decided, what information was going to be new out there, and they were the central authority, and then they sent it out. But as I said, with a blockchain, things kind of are different than a blockchain, because with a blockchain, there's no central authority. That it's decentralized information. Everyone's kind of updating everyone else and sending information out to everyone else. And it's basically a consensus network. So the more people that agree with the information, that information is usually considered valid as well. And like I said, if you have taken the first course, I'm adding a little more information here than we did on the first course, but also going back a little bit for the people that haven't. But as I said, it's a consensus network. Essentially, that's the term that's being used. The history of blockchain and we covered this in the first course, was originally to keep track of like date and timestamps on contracts, because in the digital world, like contracts can be manipulated pretty easily, and that was the power behind blockchain, right? Is to basically, like, if you have something physical, like if I take a dollar bill and I do a counterfeit dollar bill and I print it on my inkjet printer, you're gonna be able to tell that's not a real dollar bill. But like in the digital world, I can just copy and paste bits, right? It can be a like for like copy, and that becomes a problem. And blockchain was originally there to solve that problem, right? To basically solve that issue. And like I said, it was basically popularized by Satoshi Nakamoto, the creator of Bitcoins. And of course, like we know, there's some controversy by who Satoshi was, and exactly. There's a lot of controversy behind that that we covered in the first course. But as I said, the most basic form of a blockchain is just a ledger. It's just something to keep records on. That's what a blockchain is. From a Bitcoin perspective, right? The Bitcoin domain as a blockchain was, it was the first kind of real blockchain. It is so cool. Like if you read more about Satoshi, it is so cool, like what he did, because like I said, he took blockchain technology, which was around well before, Bitcoins were. And, he's the pretty much one that popularized that, and he's the one that really thought about that. And then even proof of work was not really, it was originally, used for something totally different. And then he kind of popularized that, and it's like, oh, man, this makes so much sense. And really like kind of putting these technologies together in such a way. I mean, like I said, I don't know who the guy was, or like woman, entity, government entity, but the entity was, in my opinion, a genius, right? Because like I said, and I recommend everyone still reading his white paper. You can still like read the white paper. I think it's 31 pages, if I remember correctly. Very simple. It's changed quite a bit, but it's an easy read for the most part, and it's still kind of cool to see like all the things like this. He was forward thinking. Every blockchain that you look at since Bitcoin has kind of taken, I think, the best parts of Bitcoin, but it hasn't really replicated it completely. I still think Bitcoin really has stood this test of time. Ethereum comes close, but Ethereum has definitely had problems that blockchain hasn't. Ethereum had like a logic problem in the mass that when it first came out, that allowed things like double spending and people reusing coins. It had like a lot of different issues that Bitcoin never had. But like I said, his paper was basically allowing transactions like spending money without a central bank or authority. And the Bitcoin network actually came online on January 3rd, 2009. Satoshi Nakamoto, like I said, whoever he was on forums, he was on other places. But in like 2011, he pretty much said like, guys, I'm out of here, right? I'm done, and I've given my baby to the world. The first Bitcoin blocks had a reward of 50 Bitcoins. That means miners that actually like mined, and we'll talk a little bit about mining here, but the first miners that actually mined, you basically got a reward of 50 Bitcoins. So anytime you mined and verified a block and you solved that block, you got 50 Bitcoins. People always like speculate like why Bitcoins were around. Like this was a message that was in the first block. The Times, January 3rd, 2009, chancellor on the brink of second bailout for banks. I always speculate that he wasn't a government entity, that he was kind of tired of what was happening with central authorities and too big to fail, and maybe that's why he created Bitcoins. Or keep on saying he, but like I said, we don't know who it is, but that's just a saying. Bitcoins are valuable. Like I said, a lot of you have gone for the first course, so we're not going to cover all this. But like I said, Bitcoins are valuable because they can be rare, right? There's a finite supply of Bitcoins. Only 21 million can exist. And as of June 2018, 19 million Bitcoins were mined. Bitcoins, they can be transferred and manipulated in really small amounts. So, pennies if needed. And like I said, it's been estimated 25% of Bitcoins we mine. Because of the halving of Bitcoins, we'll talk a little bit about halving as well. It's assumed that the last Bitcoin won't be mined until 2140. that doesn't mean like Bitcoins will be being used by 2140. It means the last one at its current rate will be mined by 2140. So what is Bitcoin halving? Well, for every 210,000 blocks, the reward for the payout of the block is cut in half. So in theory, as more Bitcoins enter circulation, the less that are available for newly minted coins. Like in theory, this should help inflation. We've seen things like for the first time, this is being questioned because we have a lot of inflation right now, and we've seen that affect the price of Bitcoins. So there could be just weird things happening with like people speculating because it's such a speculative market as well. But like I said, in theory, like mathematically, this should have helped inflation. As I said, if you remember correctly, the first reward on Bitcoins was like 50 Bitcoins. After after the first 210,000 blocks, the reward was reduced down to 25 coins. Then then it was reduced down to 12.5 coins. As of May 11th, 2020. It's the reward is 6.25 Bitcoins per block, but Bitcoins are like 23,000. So a block is what, like 150,000, something like that dollars. So like every time you mine a block, it's $150,000, and that money could go up in value. Like if Bitcoins hit like $100,000, who knows? It could you keep on to those coins. There's a lot of money in Bitcoins potentially. Why is Satoshi still unknown? Because he wants to be, or they want to be. It wants to be. I think that's the main reason. If you look back at his post, and this is my opinion and Mara's opinion, of course, not an official thing from the Bitcoin Foundation, but I think like Satoshi was always about the technology. He wanted to give something to the world. Even if you look at like some of his old posts, anytime someone asked him something personal, he just ignored that and really just like went down to business. So I think I think that's why. Who's the Bitcoin hype man? Like, you mean who's hyping Bitcoins the most, or who's like anyone that is trying to make money or do pump and dump? I don't know, Elon Musk at this point, but I don't know why he disappeared. In my last class, I told you there's been a lot of people that have said that there's Satoshi in the past, and people have asked like, hey, sign something with your PGP key or something that you've used on the forums that we knew was associated to you back in 2011, and they've never done that. They've always come up with some excuse. They haven't done that. I think it would be pretty easy for someone to prove that there's Satoshi, but they haven't done that. So I haven't seen any real proof. No matter what anyone says on Satoshi coming back, some people, there was a forum post in 2015, a guy like claiming to be Satoshi, saying like making a pretty public and political statement that seemed like kind of true to the nature of Bitcoins, to the kind of the to the heart of Bitcoins, what he was making in his statement. But like I said, I don't think it was him. It would be pretty easy, I think, for Satoshi to prove who he was. I'm not going to be discussing yield farming. That's actually I didn't even put that in the course. It's a good point. Maybe I'll try and touch on that if we can. But if not, and you want to talk about it, please email me. I'll probably add that to the course. I hadn't, like I said, really thought about that, but that's a good point. So sorry about that, HL. Let me just quickly go through this. I said, like, I know a lot of people have already seen this, so I'm going to make this really fast. So proof of work, like I said, proof of work was actually created to fight spam email back in 1993. So the technology has been around for a while. It was formalized in 1997. I already told you that proof of work is like a puzzle. It's basically a puzzle for the computers to solve. We talked about this in class 1. It's basically a puzzle that can be verified easily. Like the answer can be verified easily, but getting to that answer takes a little bit of work. There's a lot of reasons for proof of work. Basically, it slows down the creation of blocks. It adds predictability. It adds like computing power. It's almost busy work for the computer to work, to solve. Like in Bitcoins, the proof of work takes approximately 10 minutes. That's why we have 10 minutes between the creation of each block. And to like verify those blocks. So basically, that delay adds a little bit of predictability into it. And then we talked quite a bit in the original class. Like you can't really tamper with the proof of work because you got to tamper with a lot of different things to tamper with the proof of work. Just because the way blockchains are connected through blocks, right? So I kind of gave this example, from a proof of work. Basically, if you have like a variable, say you have, x times y, equals some number like z, right? And so a proof of work would be something like hey, we know x is 5. 5 times something equals an answer, and if we hash that answer, does the hash end in 0? And I went through this in detail in the last class, but if I take 5 times 0, the answer is 0. Then if I take the hash of 0 and I look at that hash doesn't end in 0, right? If I take 5 times 1, the answer is 5. And if I hash the answer of 5 and I look at that hash, that SHA-256 hash, does it end in 0? No, it doesn't. I won't get you that answer until I take 5 times 21. If I take 5 times 21 and I get an answer of 105, and then I take the hash of 105 and I put it through the SHA-256 hashing algorithm, at that point I'm going to get a hash that ends in 0. And that's the answer. That's a very, very simple example of proof of work. Believe me, proof of works are not that simple by any means. That's just an example of basically having a problem that you have to solve, and it's easy to verify what the solution is because you can just look at to see if that the last number ends in 0. But to actually compute that takes a little bit of work and power. So Bitcoin miners, like I said, for the most part, Bitcoin miners, they get these rewards and blocks, and the Bitcoin miners is pretty essential to the Bitcoin network because miners pretty much legitimize these transactions. As I said, these miners receive rewards for completing blocks, and that's what the reward is. And we get newly minted Bitcoins. And then, like I said, these mining rewards are paid for miners who solve the puzzle. Now, because miners are relying on computing power, the person with the most computing power is going to be most likely to solve a block, the proof of work in a block. So the more computing power you have, the more chances are you're going to be able to collect on that reward. And how do you get computing power? Well, you spend a lot of money. You spend a ton of money by buying lots of computing power, paying lots for electricity, paying lots for GPU and ASIC cards. And once you have that, you're very, very likely, to have a better chance of, solving the proof of work. That's why a lot of miners work in pools, because pools are just collections of everyone sharing the computing resources. And you can have pools with hundreds and thousands of people in them, and you have a ton of computing power right behind you because you're all kind of distributing your computing power. And that means that's why almost every block that's solved is solved by a mining pool and not by individuals. You really have to have just a lot of luck. I forgot the chances. I think if you're an individual computer, something like the current chances is 1 in 22 million per block that you'll actually solve a block. But other than that, it's to get the reward, you have to solve the block or actually come closest to the block answer and be the first one. So if you're the second one, you get nothing. If you're the first one, you get the reward. So think of Bitcoin miners as auditors, and then like I said, miners are really there to solve the double spending problem. That means it prevents a bad actor or a hacker from basically using his Bitcoins twice to buy the same things. Those miners kind of stops that. And then as I said, as of if Bitcoins are worth 22,000, at least they were yesterday. Today they're 23,000. But if they're worth 22,000. Then basically that means you get 135,000, per reward. If you're in a mining pool, you're obviously dividing that by the pool members, and how you're dividing that is dependent on the pool rules. So depending on what you're running, you may get $100 or $1,000 or who knows, but usually it's divided by the pool and the rules of the pool. Just to show you like how much it takes to mine bitcoins. So like they say mining bitcoins basically takes 143.5 terawatt hours. That's like more electricity that's being used to mine bitcoins in a year than that's used by the countries of Ukraine and Norway put together. That's about enough to power 500,000 U.S. households per year. And that's kind of like fuzzy back of napkin paper math here, but it's pretty close from like averages that I pulled up. So that is a lot of power, right? And a lot of people just consider that wasteful. A lot of people just think like, okay, like you're really just kind of making up currency. You're making up value. You're only valuing it because you think it's valuable. There's no intrinsic value. Like Bitcoins doesn't give me oxygen to survive. So we're just kind of creating value out of thin air, really, and we're wasting a lot of power. And we live in a world where environment and other things are like definitely being looked at. So like, how much energy are we wasting just by running computers to solve problems? Because computers get hot. These ASICs and GPUs get hot, and it takes a lot of power and a lot of these usages to basically solve these problems. I'm gonna skip this a little bit. If you guys are not familiar with this, please just email me. But we covered this like in the first course quite a bit, and like the majority of people, when they gave me the thumbs up, they told me that they had